Recording in progress.
So time is 9 months. Okay. And principal, how much is the principal, Abraham?
Ma'am, principal is rupees 500.
Very good. 500 rupees is my principal in this question. Okay. So I have to find out CI. So first I'll use the amount formula. That is amount is equals to principal 1 plus. Now this in this question it's saying that compounded quarterly. Okay. Quarterly. And time, when you are given time in this thing, when you are given time in months, you divide the number of months with year. Okay, you divide that number of months with year. Okay, so it becomes 9 months becomes 9 by 12. 9 by 12. Okay, and it becomes 0.75
Ma'am?
years. Yes, Edric.
Ma'am, why 9 by 12?
Because in a year, yes, in a year, 12 months are there. So when you are given in months, to make it in this thing, to make it year, you divide that months into with 12. Okay, you divide it with 12. And then because it's compounded quarterly, to get the time, we will do 0.75 into 4 because 4n is there, so n becomes 0.75. This 9 becomes 9 by 12, okay, which becomes 0.75. Okay, now n, 4n, it is there in the formula. Okay, I'm writing here in the formula. P 1 plus R by 4 by 100 raised to the power 4n. So n is 75, multiply 0.75 with 4. Okay, so we will get how much? 3. Okay, so I'm writing here amount equals to principal, put the values 1 plus R by 4, that is 20 by 4 by 100 raised to the power 0.75 into. Okay, so amount.
3.
Yes, 3. And 20 by 4 becomes how much? 5. Okay. So 1 plus 5 by 100 raised to the power 3. Okay. Now you can solve it. P here, instead of P, write 500. Okay. Write 500 because we are having the value of P, 500. Okay. 500. Now we can solve this. Okay. Take LCM. So it becomes amount equals to 500. Inside the bracket 105 by 100 raised to the power 3. Okay, so cut it, cancel 21 by 20. Okay, so here I'm writing amount equals to 500, 21 by 20 whole square 3. Now you can open it. Amount equals to 500 into 21 upon 20 into 21 upon 20 into 21 upon 20. Okay, now cancel 2 zeros. That's 5. Okay,
Ma'am, I have a question, ma'am. Why are we not using 21 upon 24 times?
3 times I have written because it is raised to the power 3. Okay, raised to the power 3 here. So that's why I've written it 3 times. Okay.
Yes, ma'am.
Yes. Now amounts equals to multiply 21 into 21 into 21. So I will get 9261. Please check someone's please remove this, whoever has made this square thing. Upon 16. Okay. Now divide it. 961 divided by 16. You will get the amount. Okay. So I have my amount 578.81. Now find the CI. CI is how much? Amount minus principal. So 578.81 minus 500. So CI is how much? 78.81 is my CI. Okay, clear, Abraham?
Yes, ma'am.
Okay, very good. Rutan?
No, ma'am. Can you just give me a minute?
Sure.
Ma'am?
Yes,
Ma'am?
Andrew.
Ma'am, I
Yes,
got
yes, ma'am.
78, 13 by 16.
13 by 16. That's also correct. Okay, that answer is also correct. You got in a mixed fraction. Okay, same as this one.
What did
Decimal
you
only.
write? Just at the first one, A equals P, then the brackets 1 plus R by 4 by 100. Then what did you write after that? Is it 4N?
4n.
Just 8.
Yes, yes, 4n. Okay, 4n. Yes. Okay, so Abraham, you're having doubt in the fifth question of this exercise also, right? 9.1 fifth question also.
Yes, ma'am.
Okay. So see, same thing is followed in the fifth question also. Okay, it's compounded quarterly, Abraham. So divide the rate by 4. Okay, you divide the rate by 4, and in the power, you take raised to the power 4n. Okay, you take raised to the power
Ma'am, I got
4n.
rupees 3600. Amount is 3600 in that. Is that the correct answer?
3600. Okay. Let me see. 1 minute. Check again, Anaya. You will not get 3600.
Ma'am,
You will get
now it's
570.
logged on 4 devices.
Anyways,
There are 4 NXTNs.
that's because of the sharing and all. So have you guys written it? Check it again, Anaya. Check it again once. Please check your marker or pen or whatever. It's I think moving on the screen again. Whoever it is.
Ma'am, will it be 5 by 100 again? 1 plus 5 by 100 instead of 20%?
Which part, Anaya?
9.2 question number 5.
Will it be? What did you ask?
5% again instead of 20%.
Yes. Yes, Anaya. It will be 5%, okay? Because it's compounded quarterly, we divide it with 4. Okay? Because
And it'll
it's
be raised to
compounded.
the power, ma'am, 4 or 3 again.
Raised to the power 3. Yes. Because quarterly, so 0.7, the months. Look over here. I have done it over here. See. 9 months, we make it 0.75. Rate, this is 20%. So you divide 20 with 4 and it becomes 5%. Okay, it becomes 5%. Now got it? Written, shall I clear the screen now?
Yes, ma'am. I have written long time.
Okay. Anaya and Idris Simeon, I'm going to clear the screen now, okay?
Yes, ma'am, copied.
Okay. Yes. So 9.25, Abraham, I will give you a quick overview on how to solve this. Okay, this is the same as the previous one. Okay, you can try this. Okay, the principal in this one, I'm having 2,500. Okay, 2,500 is my principal. Then I'm having rate. Rate is 20%, and I'm having time 6 months. 6 months. Okay, now the question is saying that it's compounded quarterly. Okay, okay. This is being compounded quarterly. So 6 months becomes 6 by 12. Okay, 6 by 12. So 0.5. Okay, multiply it with 4. If I multiply it with 4, because it's being compounded quarterly. So we do NT. Okay, means or 4. Yes, we do 4n. Okay, means this is my n into 4 in the power. Okay, in the time. So this becomes 2. Okay, so this is your n. Okay, n will be 2. All right, and this is compounded quarterly. Okay, so r will be 20 by 4, 5% again. 5% again. Okay, then you can put the amount formula just like this. Okay, 2500, 1 plus 5 by 100 raised to the power 2. Okay, you can solve this amount you will get, then put this EI
Ma'am, I
formula.
got 689.06 rupees.
689.06. The compound interest.
Not the compound interest, ma'am, the amount.
Okay. Um, check it again. Check it
Someone's
once
keeping
again.
on
Okay.
shaking the screen.
Sorry. amount you will be getting, if you solve this, amount you will be getting 2,756.25. Okay, this you will get. This is your answer. How I solved it? Just solve for the amount.
Ma'am,
Yes,
ma'am, I also got 256.25 only.
yes, answer will be 256.25. Okay, 21 by 20. Then expand it. Okay, cancel the zeros. Divide it. Then you will get 2,756.25. Okay, then this is your step 1. Then here is the step 2. Okay, to find the this thing, compound interest. Okay, Abraham clear?
Yes, ma'am.
Okay, Anaya, is it clear?
Yes, ma'am.
Okay, very good. So just let me know when you have written it. Okay.
Done, ma'am.
Okay, Abraham written.
Yes, ma'am.
Okay. Yes. So moving on to exercise 9.3. Tell me your doubts of 9.3. Okay.
Yes, ma'am. I have 3 doubts.
Yes.
Ma'am, the first one is question 1 itself. 9.3
Okay.
question 1.
Okay. So we will do 9.3 question 1. Now there is a major thing with this question. Okay. I checked it out, and there is a misprint in the par. Okay. In the T, there is a misprint. It's not 24. It's not 24.
That's what I
It's
got confused in, ma'am. It was showing 24 years.
Yes, 24 years. Okay, so cut it and write 2. Okay, it's not 24. Check this question. Okay, it's 2.
Okay.
All right. Yes, it's 2. And I'll show you solving it. Okay. Um, solve
P
it
equals to
also.
2163.20.
Yes, A equals to 2163.20. Then P we don't have. Okay, R is 4, and this 2. Okay, it's not 24, it's 2. And okay, so let's solve it now. It's compounded annually. Okay, so use the amount formula. Amount equals to principal 1 plus R by 100 raised to the power 2. Okay, so amount is 2163.20 equals to principal 1 plus 4 by 100 raised to the power 2. Okay. Now, this point we are having here. Okay. So I can remove it, and put 100. Remove it and put 100. Okay. Now this 0 of 100 and this 0 can be cancelled. 0 with 0 can be cancelled. So my number becomes 21632 by 10 equals to T 1 plus 4 by 100 raised to the power 2. Now, I told you that we can cross multiply like this. Okay. So it becomes, here I can write it like this, 2, 1, 6, 3, 2 divided by 10p, 10p equals to 1 plus 4 by 100 raised to the power 2. Okay, 10p. Now I have 21632 by 10p. Okay, now you solve my right hand side. Now we'll solve my right hand side. Okay, how?
Ma'am, it's
Just
26 by
simply take the,
25.
yes, 26 by 25. We take the LCM, cancel them, 52 by 50. Cancel more, you will get 26 by 25. Okay, so 21632 by 10p equals to, first you will get 104 by 100 if you take LCM. Okay, now cancel. Okay, you will get 52 by 50. Cancel more, you will get 26 by 25. 25 raised to the power 2. So I'm writing the next step here. 21632 divided by 10p equals to 26 by 25 square. Okay, now open it. Okay, and p is also yeah, now open it. So 21 632 by 10p equals to 26 upon 25 into 26 upon 25. Now cancel them, okay, and it will be, oh sorry, cancel, you multiply it, okay, multiply because cancellation is not possible. 10p equals to 676 by 676 by 625. Okay, now we will p, okay, equals to 625. Reciprocal will happen here, okay, because I'm taking 21632 on this side, okay. So I told you all that when we are taking a number on another side,
Ma'am, it will be
reciprocal,
625 into 21632 divided by 676, right, ma'am?
right, that's right, okay. So 21632 into 625 divided by 676. Okay, now cancel them. Which two you can cancel?
2, ma'am.
Yes, let's do. Okay. Now multiply it. Okay. You will get 380 divided by 169. When you divide this, you will get 20,000. Okay. You will get 20,000. Now 10p equals to 20,000. 10p equals to 20,000. So p will be 20,000 divided by 10. 20,000
It's
divided
2,000.
by 10.
It's 2,000, ma'am. P is
Yes.
2,000.
So my right. So my p is 2,000. Okay. That's how you will solve it. Okay. So there was a mistake, printing mistake in this question. In the time, in the number of years. Okay, it wasn't 24, it was 2. Okay. I hope this question is clear for everyone.
Yes, ma'am.
Okay.
Yes.
Edric, is it clear? Abraham and Sameer?
Yes, ma'am.
Okay.
Yes,
Okay.
ma'am.
Okay.
Ma'am, I have 2 more doubts in 9.3 itself. The next one is
Okay.
question 3, ma'am.
Question 3.
Yes,
Okay,
3.
we'll solve.
9.3, question number 3.
Okay. So I hope till here your doubt is clear.
Yes, ma'am. Thank you.
Okay, written then.
Yes, ma'am.
So I'm clearing the screen, okay? Going to clear the screen now. Third question we will see. Put the values. Now, CI I'm given in this question. CI
Ma'am,
I'm given.
832. What?
Yes, 3, 2. Okay. And rate is given
8.
how much? 8%. Okay. Time is given how much?
2 years.
2 years. Very good. And it's compounded how? Annually.
Annually, ma'am.
Yes. Compounded annually. Okay. So let's solve it. First, you use the amount formula. Okay. That is amount is equals to principal 1 plus r by 100 raised to the power n. Okay. Now put the values. Amount we don't know. Principal also we don't know. 1 plus rate is 8 by 100 raised to the power 2. Okay. Now see guys, there are 2 ways to it. Okay. Any of it you can use, but answer you will get the same. Okay. Right now, okay, because sometimes when you are not given A and P boards, it is like easier to do it in decimal. So I'm showing in decimal. You can do this in fraction as well. Okay. You can do this in fraction too. So this 8 by 100, I'll convert it to 0.08. Okay, you know how that comes? Okay, because
Yes, ma'am.
yes, so amount equals to principal 1 plus 0.08 raised to the power 2. Okay, raised to the power 2. Now I'll first add 1 to 0.08. Okay,
Ma'am, that equals to 1.08.
yes, that equals to 1.08. 1.08. You can do this in fraction as well. I'm telling again. You can do this in fraction as well. I'm taking decimal because it's easier. Okay.
Yes, ma'am. Even I'll
Fraction.
in decimal because it's easier.
Yes. Okay, in decimal it's easier. Fraction also you can take. Okay, Adrit, no problem. Fraction method is also correct. Okay, so now do do the square of 1.08. You will get 1.1664. Okay, so this is my first equation. This is my first equation. Okay, now what I will do, I will take the compound interest formula. Okay, that is compound interest equals to A minus P. A minus P. Okay. Now, CI I have 832, 32. And amount I have here. This is my A. So P in the bracket 1.1664, I'm going to use as my amount. Okay. P 1.1664 minus P as it is because I don't know the P. So minus P as it is. Now what I explained that when we have a single variable, it means that its value is 1. Okay. Can you put the screen to normal size back, Abraham? Um,
Ma'am, I am not Abraham, ma'am.
okay, Edric did. Okay. Anyways, so now what I was telling you, yeah. What I explained that when we have a single variable, it means that its value is 1. So P's value is 1. So I can write it like this. How? I can write it like this. 832, 32 equals to. Can you scroll the screen up a little bit, Edric? 1.1664 minus 1. Okay, minus 1. Subtract 1 from 1.1664. You will get 0.1664. Okay, so 832 equals to principal 0.1664. Now I will take P on, 1664 on this side below 832. Okay, so I will write 832 by 0.1664 equals to principal. You divide it and you will get principal 5,000. Okay, P will be 5,000.
Ma'am, that means amount is 5,832.
Here's the answer. Amount is 5,832. Okay, I'll show you quickly writing. Your CI is A minus P. So if I take my P on this side, I will get A. So I can do amount equals to this P is minus becomes plus CI plus P. Okay, so 5,000 plus 832, 5,832 is my amount. Okay, is it clear?
Yes, ma'am. Thank you.
Okay,
Done, ma'am.
done. Okay,
Yeah, my next doubt is in index question 9.3, question number 5.
fine. Okay. So is it clear, everyone? Edric and Simeon Abraham present?
Yes, ma'am.
Okay, very good. So 9.5 is your doubt. Okay, let's see 9.5. Can you tell me the values?
No, ma'am. 9.3, question number 5.
Yes, 9.5, question number 5.
Ma'am, the value is A equals to rupees 3025, rate equals to 10%, 3025, ma'am. 3025 amount.
Right. Rate is 10%.
N equals 2 years.
Okay.
Compound yearly. Principal is not given. You have to find the principal.
Okay. Let's solve this. First is the amount formula. As always, amount equals to P 1 plus R by 100 raised to the power 10. Okay, amount and principal amount we have, that is 3025. Put 3025 at the place of amount. Okay, then write P as it is. Then 1 plus R is 10 by 100 raised to the power 2. Okay, now solve the right side first. Okay, that is 3025. Take the LCM. It becomes 110 by 100, which becomes 11 by 10 because we cancel the zeros. Write it 2 times into 11 by 10 into 11 by 10. Okay, now multiply 11 with 11 and 10 with 10. 11 with 11 is 121 and 100. So it becomes 3025 equals to, now P into a number is that number P. Okay, that is P into 121 is 121P. Okay. So 121P upon,
Ma'am, could you go a little slowly?
sure, I'll go slowly. Okay, so 3025 equals to P into 121 is 121P by 100. Now here I can do cross multiply. Okay, so here it becomes 121P equals to 3025 into 100. Okay, now this 121 I can take here below 3025 into 100. So my P will be 3025 multiplied by 100 divided by 121. Okay, now you can cancel 3025 and 121. That's 121 itself.
Ma'am, they both can be cancelled by 11. 3025 and
Yes.
121.
Yes, you can cancel with 11 or 121 directly. Okay, you'll get the same thing. $2,500. Okay. Is that clear?
Yes, ma'am. Thank you.
Very good. So anybody else has any problem in this exercise? 9.3. Edric, any other doubts?
Ma'am?
Yes, Beta.
No, ma'am. I don't have doubts in
Oh,
this.
okay. Abraham and Simeon, any more doubts in this exercise?
No, ma'am.
Oh, okay. Simeon,
No.
okay. Good. Have you all written this?
Yes, ma'am.
Okay. I'm clearing the screen now. Yes. So we will move to exercise 9.4.
Ma'am, my first out of 9.4 is question number 2.
Ma'am,
Yes, Anjali.
ma'am, sorry, ma'am. Even I also have doubts in question number 2 and 5.
Okay, no problem. We will solve them together. Okay, we will solve them together. So tell me the values of the second question.
Yes, ma'am. The second question is A equals to 9680.
Then
R equals P equals to 8,000.
8,000.
Then N equals to 2 years. No, 1 year. Sorry.
1 year.
And it's compounded half yearly. We have to find the rate in this question, ma'am.
Okay, compounded half yearly. Hence, R we have to find out. Okay, so see what we do, guys, in like compound interest, every question, whatever you have to find, use the amount formula first. Okay, so amount formula is what amount is equals to principal 1 plus, now this is compounded half yearly, means R by 2. Okay, R by 2 raised to the power 2n. Now, why I'm not using 100? Why I'm not using 100 right now? Because it will be in fraction, okay? So instead of like you can use 100 here also, but it will be easier if you use 100 at the end, okay? It will be simpler. Here, if you use 100, you might have it might cause you confusion, okay? So that is why I'm not using 100 right now, but I will use 100 at the end. Okay, how? I'll show you. So amount is 9680. 9680 equals to 8,000 is my principal. 1 plus R is how much? We don't know. So R by 2 raised to the power 2. Okay, because n is 1, so 2 1 1 2. Okay, now this 8,000 we can take here. Okay, this 8,000 we can take here below 9680. Okay, so because we take variables on one side and numbers on one side, okay, because of that concept. Okay, variable one side, number one side. Okay,
Yes,
so
ma'am.
that is why we will take
I tried doing
8,000.
it this way only, but I was still not able to do it.
No problem. Let's do it. By 8,000 equals to 1 plus R by 2 raised to the power 2. Okay, now divide 9680 and 8,000. Okay, divide 9680 and 8,000.
Ma'am, the answer I got was 121 by 100.
121 by 100. Or you can do 1.21. Okay,
Ma'am?
1.21.
Or let's put a decimal.
We can put decimal. Okay, because we are because in decimal, when we are using in decimal, it makes it easier. Okay, so 1.21 equals to 1 plus R by 2 raised to the power 2. Okay, now 1.21 here I will take that by what number? What's the number when I multiply it with itself? I will get 1.21. Okay, square root of 1.21 because here it is square root and I need to remove the square root. So here also I take square root. Okay, so if I do 1.1, okay, is my square root of 1.21. 1.1, then equals to 1 plus r by 2 raised to the power 2. Now you can cancel the square root of 1.1 and 2 both. Cancel from here and cancel from here. Okay, so I will get 1.1 equals to 1 plus r by 2. This I will get. Okay. Now there is one step, guys, that we have to follow when we are calculating the r. Okay. And when we have such type of value, one step that we need to follow is subtract 1 from both the sides. Okay. Subtract 1 from both the sides. To get the value of r, we need to subtract 1.
Ma'am, that equals to 0.1 equals to r by 2.
Yes, that's right. So 1.1 minus 1 equals to 1 plus r by 2 minus 1. So plus 1 and minus 1 I can cancel. And 1.1 minus 1 is 0.1. So 0.1 equals to r by 2. Okay, now I can cross multiply 0.1 and 2. Okay, I can cross multiply. So I can write r equals to 0.1 into 2. R is 0.2. Okay, now R is in percent. Okay, this 100 that we removed at the start, we are going to multiply it here at the end. Okay, so R percent, rate percent equals to 0.2
20%.
into 100. Yes, R
That equals
percent
to
equals to 20%. Okay, hope you guys have got this question now.
Yes, ma'am. Thank you.
Yes, ma'am.
Oh,
Ma'am, got it.
Ma'am, my
okay.
next doubt is in question number 3.
Ma'am,
Yes, Cedric.
question number 5.
5.
Ma'am, do the doubts
Okay,
tomorrow. It's time.
it's time. वैसे तो yeah, it's time, right? Um, shall we take 5 more minutes?
Okay, ma'am, I'm fine with that.
Edric, you okay with it?
No.
Why you gotta go in another class? Okay, so I hope you guys have written this. Still here now?
Yes, ma'am.
Okay,
Yes, ma'am.
okay. Very good. So, what are your doubts, Naya? You're having in third question and fifth question.
No, so ma'am, in text questions, question number 225, 225. So I have it in 2, 3, 4, and 5.
Okay, and Edric, you?
Only 5.
Only 5. Okay. Okay, then we will stop now. We'll stop it here and we will continue your doubts in tomorrow's class. Okay.
Okay, ma'am.
We will continue. Yeah, because it's time already and we'll continue your doubts. We can explain all of doubts, further doubts in the next class. Okay. Okay, Brita, see you. Bye. See you tomorrow.
Ma'am, is homework
Bye,
in
ma'am.
text questions 9.5 and 9.6?
Yes, today do the homework of index questions 9.5 and 9.6. Okay. We'll take its doubts tomorrow. Okay, along with 9.4, we will take 9.4, 9.5, and 9.6. Okay, all of the doubts I'll take. All right, so finish up exercise 9.4, 5, and 6 today. Okay, and the next 1 or 2 classes, we can take doubts of all of the whole chapter. Okay, okay. Okay, Edric. See you then. Bye.
Bye, ma'am.
Bye. Okay, guys. 3 minutes break till 4 o'clock, and then we will begin. Okay.
Ma'am, we will begin. We will science class will till what time? 4:40.
Science class will be till no, not till 40. Okay. It will be a shorter session. I think till 4:25. Okay.
Ma'am, you're on mute.
So this is right from the uses of metals and non-metals. Right. So now there are a lot of uses, okay, of metals and non-metals. They are used for various purposes. Okay. They are Metals are used in making industrial gadgets, buildings, vehicles such as cars, aircraft, trains, satellites, cooking utensils, furniture, camera, fridges, etc. In almost every item necessary for life, metal is used in some form. Okay, so these are some uses of metals. Okay, how metals are used. Now there are non-metals. Okay, they also have various uses. Okay, and oxygen is such non-metal which all living beings inhale. Then a number of medicines are prepared from non-metals. Graphite, mica, and diamond are non-metals. Diamond is used to make jewelry and cutting tools. Graphite, mica, all of these are used in the construction of a house, right? So they are used. Then chlorine is a non-metal used in water purification. Then many non-metals were used as fertilizers, and potassium nitrate is used in crackers. Graphite is used to make pencil leaf. Okay, so they are the uses of non-metals. Okay, can you all give me one example of a metal and its use and one example of a non-metal and its use?
Um, Ma'am, iron is used for like iron is a metal and it is used for different things such as it sometimes can be used for making furniture sometimes, like, or like utensils or something like that.
Yeah, right. And non-metal. Anyone wants to give an example of non-metal and its use? Yes, Simran.
I didn't hear what you said. 1 second. 1 second.
Sure.
Okay. What did you say?
Example of a non-metal and its use.
I think so. Okay, wait. Wood. Wood is a non-metal and it can be used for different purposes such as furniture or like tool handles or as
Okay.
firewood.
Right. Okay, good, Simeon. That's right. Yes, Abraham, you wanted to add something? Want to give an example? You can give.
Ma'am, plastic is used in toys, utensil, toys, plates, and it's used mainly in mostly in every industry.
Okay, so plastic is an example of metal or non-metal?
Non-metal.
Yes, non-metal. Okay, good. Yes. So let's talk about alloys. Okay, what's alloy? Okay, now metals are combined together. Okay, when metals are mixed together, the new thing that's formed, which is like a mixture of metals, more than one metal, is known as alloy. Okay, a new metal formed by combining two or more non-metals is known as alloy. Alloys are homogeneous mixture of metals. These are made from melting metals. Properties of alloys are different from their constituent metals. Okay, they are made from melting metals. Okay, see how it's rhyming. Made from melting metals. Yeah. So now the properties of alloys are different from their constituent metal. Okay, means the original metal. Now, if you have seen bronze utensil, bronze is an alloy. Okay, it is made from copper and tin metal. Okay, bronze utensils, bronze is made up of copper and tin metals. Okay, tin is hard and corrosion resistant, and copper is a soft metal. Okay, tin is hard and corrosion resistant, and copper is a soft metal. Okay, similarly, iron is brittle. It easily forms rust. Okay, iron easily forms rust when it reacts to the oxygen. Okay, when it reacts to air and water. Then, but if it's mixed with carbon, it becomes steel alloy. Okay, it becomes steel alloy.
Ma'am, I have a question, ma'am.
Mhm.
Carbon is not a metal, so how can carbon is a gas is a non-metal? It's a gas. So how can it be considered as an alloy?
How can it be considered as an alloy? I think it's not talking about that powdered carbon. Okay, I think it's not talking about that form. Okay, I think before it's mixed with iron, it is like processed. Okay, to bring it in a more solid form, and then it's, I think, melted to be mixed with iron to form a steel alloy. Okay, that's a whole process. Okay, we gotta look into it and see how it takes place. Okay, so that's how. Then iron, when iron is mixed with nickel and chromium, we get stainless steel. Okay, you might have heard stainless steel, this thing, utensils. Right, so
Yes,
when
ma'am.
iron, yes, is mixed with nickel and chromium, we get stainless steel. These alloys are strong, hard, and corrosion resistant. Okay, strong, hard, and corrosion resistant. If it's just iron, it will not be corrosion resistant. Okay, rust will form. But if we mix it with another other metals such as nickel, chromium, it will not get rusted easily. Okay, it will become corrosion resistant. Okay, then we have alloy. Then this table tells about alloy, which constituents it's made up of. Okay, means mixing of which metals it's made up of, and then what it is used for. Okay, its uses. So we have steel. Steel is made up of iron and carbon. I was telling carbon. I was reading carbon. Means iron plus carbon. So it's not carbon, it's steel. Okay. Then it's used to make bridges, buildings, railway lines, tanks, ships, routes. Okay, then we have stainless steel, which is made up of iron, nickel, and chromium. It's made up, it's used to make utensils and surgical instruments. Okay,
Now
then
I have a
we have
question on stainless steel. I have a question on stainless steel. How can stainless steel be stainless steel when it doesn't contain carbon? The steel
when
is
it
made
doesn't
out of
contain
carbon.
steel is made up of carbon
So how can
because
it be stainless steel when there is no carbon in it?
iron and chromium, sorry, nickel and chromium also has those properties. Okay, nickel and chromium, which are the constituents of stainless steel, also has those properties. Okay, so when we are mixing nickel and chromium with iron, it becomes steel. Okay, it becomes stainless steel. Okay, so nickel and chromium are also having those properties. Mixing it up with iron, it becomes stainless steel. Okay, that's how. Then we have bronze. When you mix copper and tin, you will get bronze. That's used to make coins, utensils, statues, jewelry, etc. Okay, then we have brass. Okay, when you mix copper and zinc, you get brass. Okay, then it's used to make utensils, machines, musical instruments, statues, etc. Okay, then you have nichrome. Nichrome is made when you mix iron, nickel, chromium, and manganese. Okay, and heating elements are made up of nichrome. Nichrome wire. Have you ever heard of it? Okay, nichrome wire or
Yes.
yes, yeah. So that's made of iron, nickel, chromium, and manganese. Okay, because it's good for heating. Then we have beryllium. This is made up of copper and aluminium. Okay, it's used in parts of an aeroplane. Okay, to make parts of an aeroplane. Then we have
Can I
algae.
see why uranium is used?
Sorry,
And I know why uranium is used. It's used in the wing.
Okay, it's used in the wings. All right. So, it's used in, yes, the parts of a plane, okay? Then we have alnico. I don't know why they didn't give it a better name. They just picked the first two alphabet. That's Al of aluminium, Ni of nickel, and Co of copper. They mixed it and named it alnico. Okay, so alnico is used to make magnets. Okay, it's a mixture when iron is combined with nickel, aluminum, and cobalt. Yes, Anaya.
Sorry, mom, it happened accidentally. I was trying to press something else.
Okay, no problem. So these are your alloys. Okay, these are what they are made up of. Okay, what you mix, which makes these alloys, and this is where it's used. Okay, then we have useful substances for construction work. Okay, now we will talk about the substances which are used in construction work, construction of a house, of a building, etc. Okay, so stone, wood, metal, brick, limestone, cement, concrete, sand, etc. are used in the construction. Okay, all sorts of construction. Then bricks are made from fired clay. First, bricks and stones were joined with clay only. After that, bitumen, resin, and lime for the separation, felt. Granite, marble, and sandstone used in natural stone for centuries. But in the 19th century, Portland cement was Portland cement was invented. Now, cement is being used for every type of house, building, bridges, etc. Okay, so let's talk about cement. Now, this is the person who invented cement. Have you ever heard this before? No?
No, ma'am.
Yeah, me neither. So, Joseph Aston invented cement. Okay, Portland cement was invented in 1824 by Joseph Aston. Modern Portland cement consists of 60 to 67% calcium oxide. Now, this is the composition of cement. Okay, what cement contains? So, 60 to 67% calcium oxide, 17 to 25% silica, 3 to 8% aluminium oxide, and 6% iron oxide. Okay, this is the composition of cement. Okay, ground limestone and ground limestone and clay is mixed in desired ratio. This mixture is heated to 100 and 150 um, Kelvin in rotatory furnace. The substance so obtained is called a clinker. Clinker is then ground with a small amount of gypsum to produce cement. This is how cement is made, okay? This is how cement is made, like what things you take together, okay? And then you mix ground limestone and clay in the ratio that you want. You heat it in rotatory furnace in this temperature, 1150, okay? And then what you will get is known as clinker, and then it's ground, means it's grinded with a small amount of gypsum, and it will give you cement, okay? It will give you cement. Now that's uses of cement. Mortar is made by mixing cement with sand and water. This mortar is used for plastering and as a binding material. Okay, you've seen that substance with which when they make bricks, they use it in between of bricks. Okay, when they're putting
Yes,
bricks,
ma'am,
they use it.
to stick the bricks together or something.
Yes, to stick the bricks together. Okay, so it's known as mortar. Okay, it is used to for the plastering and as a binding material. Okay, then there is concrete. It's made by adding cement, gravel, sand, and water. Okay, This concrete is used to construct roofs of the house, street tracks, and electric poles, etc. Okay, electricity poles. Okay, the tracks. Have you heard concrete floor or concrete pathway? You heard the term. So people make a pathway or the floor or the roof with this. Okay, they mix cement, gravel, sand, and water. Okay, then if you put iron rods in concrete, then RCC cement is obtained. RCC is used in making poles, roofs, and slabs. It is also used to make precast product by casting concrete in a reusable mold. These precast parts are used to make fridges, etc. Okay. Have you ever heard of like RCC is being done in the roof? RCC. Okay, so iron rods are there in a concrete, okay? Iron rods are there, and there are
Ma'am,
various pillars like
ma'am,
this
in the
diagram.
building the metro, they use RCC cement for the like the main track that they put on top of the poles.
Mm-hmm. Yes, they put iron rods in the concrete, okay, and make poles, okay. Now on this, with the support of these poles, your roof is like with the support of these concrete poles, your roof is constructed, okay, your roof is constructed. I remember even in our house, RCC is being done. RCC was done. Okay. So when our first floor was being made, so they made poles first. Okay, concrete and iron poles they made to support the um roof of the like to make the first floor. Before making the first floor, they did RCC. Okay, so it's also used to make precast products by casting concrete in a reusable mold. Okay, the pre-cut parts are used to make fridges. Okay, they can put it into molds also to make fridges. These poles have you seen? Okay, this is made up
Yes,
of
I've seen sometimes on the side of the road and all.
yes,
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 ma'am.
yeah. So these are made of concrete. Okay, cement, concrete. Now concrete can be
Ma'am,
strengthened by
I
adding
have a question, ma'am. What are the
yes.
poles? What are the poles used for, and why are they kept at the side of the road?
These poles, these
Yes,
poles
ma'am.
are used in like construction sites. Okay, and sometimes they're used underground also. Okay, when some underground construction is taking place, as far as I know, when some underground construction is taking place, they are used there. Exactly how they use them, that I don't know. Haven't really seen it. Okay, but
I
mostly
didn't
the
understand what you
yes,
just said. Sorry.
Ma'am, metro tunnels.
I
yes.
heard till the part you. I don't understand how they something like that. I didn't understand.
Okay, so then we are talking about what's the use of this pole. Okay, what's the use of this pole? Okay, so yeah,
Which
so
pole?
this image, okay?
I know what that is.
Yeah, but how they are used? Do you know how they are used at a construction site?
Like how they are done.
Yeah,
My uncle owns a construction company.
okay. So what is the exact purpose of these poles?
I mean, I think they're just to hold the. It's to protect the pipes inside that carry
To
water.
protect the, yeah, to protect the pipes inside. Okay. I think yes, they might be used to protect the pipes inside. They might be used when you are working underground. Okay. You're working with a tunnel or something. So they can be used underground also. So like
And
this, okay?
sometimes they're used just directly, like there are no other pipes inside.
Okay, just directly. Okay, might be. So they can be used just directly as well. Okay. When big pipes are like big pipes are needed to like transport water or something, they join them together and then make a big this thing transportation below the ground for water and things now. So that way. Now, concrete can be strengthened by adding ashes of asbestos and coal. Okay. Concrete combined with asbestos is used to make drains, pipes, etc. Concrete mixed with ashes is also used in building bridges, etc. Okay. Ashes of coal. Okay. Ashes of coal is talking about used in building bridges, etc. Okay. And then we have
You,
glass.
don't they strengthen it by putting wet rags on top of it also?
Wet rags on top of cement.
I think so, something like that.
Okay. Maybe, Samir, maybe. I haven't seen something like that, so don't know about it. So
Won't
maybe,
cement get all soiled if you put like some wet cloth on it or wet rags?
yeah, to strengthen it. To strengthen it.
No, won't it get? I'm asking, won't it get like spoiled, like soiled or
No,
something?
it's
Like
already
sand?
dried. It's already dry. It's already dried, so it won't melt after that.
No, no, it won't get spoiled. Like when I was living, so our road was going under development since it was a little bad. So what they did is they first drilled it and then in square boxes they put water in it. So after some time they let the water evaporate and the water makes the cement stronger.
Okay. All right. Um, just 1 minute, huh? Okay, am I audible to you?
Yes, ma'am.
Okay. So we studied about cement. Now we will talk about glass. Okay. And what's the constituents of glass? Okay, what is it made up of? So it's mainly prepared by melting the silica. Okay, silica is the main component of sand. Silica is heated to 160 degrees Celsius, 10600 degrees Celsius to melt
100
it.
and 600, ma'am. It's 1,600.
Yeah,
600.
1600 degrees Celsius to melt it. Silica is cooled to 1600 degrees Celsius to obtain glass. Silica is obtained from sand. Okay, it's a component of sand.
Ma'am, is how is silica cool to 1600 Celsius? It has to be raised to 1600 Celsius, right, ma'am? How can we cool to 1600 Celsius?
Yeah, it's a mistake in the book
Yeah.
itself.
It's a mistake in the book, I think so.
Either they were going to write heated or they must have forgotten to put minus in the 6.
Maybe they said cooled from 16 degrees Celsius, and they just wrote 2 instead.
Maybe. Yes. So I'll see to what degree it's cooled down, okay, to obtain glass. Now, there are types of glasses, okay? So many types of glasses. We have ordinary glass, colored glass, opaque glass, heat resistant glass, optical glass, photochromatic glass, lead crystal glass, optical fibers. Wow. Okay,
My
so
father has a photochromatic lens, and it becomes dark when he's outside. So it looks like a sunglasses outside, but inside the house it looks normal.
like a clear glasses inside the house and outside the house like a sunglasses.
Yeah, in the sun.
Okay, that's cool. I haven't seen one.
Yeah, me neither.
Yeah, sounds very cool. Okay. So silica is added to calcium carbonate, CaCO3. Okay. This is the chemical compound of calcium carbonate and soda ash, that's Na2CO3, to get ordinary glass. This is called soda glass. Soda glass. Soda glass is used to make window pane, utensils, mirrors, etc. Okay. That's your ordinary glass.
But you
With
can't
it,
drink it,
we
right?
make, you can't drink it. Yeah. Yeah. You can't drink it. It's called soda glass, but you can't drink it. Okay. So, while making glass, different substances can be added to it to get glass having desirable properties. Okay. So when we add different things in it, different kind of glasses we get. Okay. This is the ordinary one. Okay. Now colored glass. In order to make colorful glass, metallic salts are mixed in it. Okay. Metallic salts are mixed in it. For example, adding salts of iron, green glass is obtained. Okay. Then opaque glass means that you cannot see through it. Opaque glass can be obtained by adding fluoride and phosphate. Okay, when you add fluoride to and phosphate to what? To silica. Okay, then heat resistant glass. They are
Mama, I have a
obtained.
question. Mama, I have a question.
Yeah,
What is the use of opaque glass? Glass is supposed to be transparent. That's completely defying its purpose.
right.
Opaque glasses you use in like bathroom windows so that light can come in, but people can't see inside.
That's not connected.
Bathroom glass, yes, that's a good example. That's a good example, Simeon. So that people from outside cannot see inside. So that it's not visible from the bedroom or whatever room that's outside. So it's used in that, okay? In bathroom glass, light can come through, okay? Light illuminates that glass, but you cannot see through it, okay? It's not transparent, all right? So that is made when you by mixing fluoride and phosphate, okay? Then heat resistant glass. This is obtained by mixing boric oxide, that is P2O2. When it's hot, it expands very little and does not break. It is known as porosylate glass. It is also called borosyl and pyrex. Utensils made of these glasses are used in factories, labs, and houses, okay? Because they are, when like they are exposed to heat, they do not break, okay? They do not break. They are very, that's a thick glass, okay? It do not break when you pour something hot in it or you put it on fire. It does not break. Okay, then you have optical glass. The glass made by mixing potassium oxide is very hard. This is called optical glass. Optical glass is used in eyeglasses, contact lenses, cameras, microscopes, and other optical instruments. Okay, then we have photochromatic glass. So this, just like Simeon explained, it becomes darker in bright light and light color in dim light. Okay, it's inside the house. It looks like normal glass. Outside, it turns darker. Okay, silver salts are added in it. Silver salts are added in it. Okay, please prepare this portion well. Okay. So you guys got to prepare the whole chapter well. Okay, for the quiz next week. Okay, and
When is the quiz?
next week, date I'll give.
And
Ma'am,
which chapters is it? Materials chapter, ma'am.
Chapter 6 and 7. That is the previous materials chapter and this materials chapter.
Okay, and it's
Okay.
next week, and it's the quiz. Okay.
Yes, next week is the quiz. Date I'll give. And tomorrow is the science test.
For biological processes one, right, ma'am?
Yeah, biological processes 1. Okay, then we have lead crystal glass. Many artifacts are made from glass. In such things, glass is cut in such a way that the light may get reflected. Thus, objects look very bright and beautiful. To make such a glass, lead oxide, PbO, is added to it. These are called lead crystal glasses.
Ma'am,
Okay,
the
that
artifact
is,
spelling is wrong.
sorry,
The artifact spelling is wrong.
artifact
Artifact.
spelling. Yes, yes, artifact spelling is wrong. Artifacts. Yes. So, artifacts are made with lead crystal glass. Okay, then we have optical fibers. Thin fibers of highly purified glass are used in information transmission, medicine, and computer network. Okay, these are the fibers. Okay, the glass which is used in computer networks. Okay, to transmit information in your like technical things. Okay, you might have heard the term optical fibers. Optical fibers is basically used in your technological. Yes,
I
Amir.
have another class right now. So can I leave?
Yes, Amir, we are just about to end it. Okay, 7.2 is your homework for today in science, and from polymer we will continue tomorrow.
Okay.
What about bulletproof glass?
Bye.
What about? Okay, bye.
Bulletproof glass.
Bulletproof glass. Yes. So bulletproof glass is very hard, okay, and strong, okay, and it is like it can resist force, okay, great pressure. It doesn't breaks under a lot of force or pressure, okay. And
Is
what's
it
the
really
exact?
bulletproof?
Sorry.
Is it really bulletproof?
Yes, it is. Like it is bulletproof, and what I think is the bullet can't get
To
through.
a certain extent, ma'am. To a certain extent of bullets. Like
Yes, to
if you like have this big bullet, this thick, it may break.
it will break. Yes, it will break. And small bullets, sometimes just cracks can be there. When bullet is coming, cracks on the glass can be there, but it doesn't get through. Okay, some little crack might be there, but it doesn't get
Like
through like
normal glass, it won't break. Okay.
normal glasses break. Okay, but like bulletproof glass, it won't like entirely like shatter and thing. So what's the exact composition of bulletproof glass? I'll look at it. Okay, look through and I'll let you know. Okay, what components are mixed up to form a bulletproof glass? Okay, that I'll share. So that's all for today, guys. That's all for today, and we will continue this portion tomorrow. Okay, see you then. Please
Bye, ma'am.
complete
Bye,
some.
Naya.
Okay,
Bye.
bye. Bye, bye, bye.